Hello coders, welcome to the High Voltage Codechef's April Long Challenge 2021. Amazon is hiring the pre-final and the final year guys. Do apply. The key takeaways will be at the end of the video. The algorithm playlist, one of the best tools to solve all of your problems. Today the question on our plate is worthy matrix. I'll be discussing the best approach, the order of one time complexity approach with you. It's one of the best approaches for a lot of 2D matrix queries. Guys, do subscribe. It takes a lot of work behind the curtains. Let's now dive deep into the question worthy matrix. Let us get started with the worthy matrix problem. Now we have the best approach, a order of one time complexity approach, but do listen to everything what I say because everything is just connected. Let's begin. Chef found a matrix A with n rows and m columns, where for each row the cell in row R and column C contains an integer. So it's basic, it's just said there are m rows and n columns. So here we see a worthy matrix with 3 rows and 3 columns, right? And with every cell has a number in it, basically. That's it. Now the matrix has two interesting properties. One is that the integers form a non-decreasing sequence for each valid I every row. So in every row you would see that there is a non-decreasing sequence. So 2, 2, 3, 3, 4, 5, it's non-decreasing. And with the same is with the columns. Every column has a non-decreasing sequence. 2, 3, 4, 2, 4, 5, 3, 5, 5. A k-worthy matrix is a square submatrix. So a k-worthy matrix, now we are defining what is a k-worthy matrix. A k-worthy matrix is a submatrix for any integer L. So it's a submatrix, it's a square submatrix such that the average of integers is greater than k. Now k is any value which is given to us in the problem. For sake of this problem, let us take k is equals to 4. Now a k-worthy submatrix is only possible if the average of all of these values in the square submatrix is greater than equal to 4. So this, if I take this as a k-worthy submatrix, we'll just have to see that whether it follows the conditions that is imposed on us. So 4 plus 5 plus 5 plus 5 is 19 divided by 4 elements. We take the average and it comes out to be 4 point something, which is greater than 4. So this part, this submatrix is a k-worthy submatrix. We'll discuss more about it. So let's just get to the next slide. The input is basic, it's t-test cases, and then you are given the number of columns and the rows and the value of k, which is important. And then the next line follows the basic input. The output is you have to print the number of k-worthy submatrices. Now it is very interesting here. Here is where I want to say that why is it important for us to go with the order of one approach, which I'll be discussing. See here, the n and m, the number of rows, is the maximum limit of it is 10 to the power 6. So we can't go beyond order of n or order of n log n. If we try to go beyond this, right, if we frame an algorithm whose complexity is order of n square, order of n cube, sorry sir, you will get a TLE. Your code might be right, but you'd get a TLE. The online judges won't accept it. So we'll have to find an optimized solution also. That is one of the needs. Let's discuss more about it. Now let us discuss with this example that what is exactly happening, and then we'll be coming to the order of one approach, that how we are doing it. Now a naive way of thinking might be that let's just see how many square matrices are possible, and let us find the sum of it every time we get a square matrix, and then we would see the sum of it, and then we'll see that whether the average of it is greater than equal to 4. Suppose say 5 here, it is a square submatrix, it's a one element submatrix, it's greater than 4, right? So there are 3 5s present and 2 4s present. They are also greater than equal to 4. So the number of k-worthy submatrices already is 1 2 3 4 5, already 5. Now next, this if you consider this submatrix and if you consider this submatrix, these two submatrices, square submatrices, are k worthy. If you add all of them and divide them by 4, you'd get something which is greater than equal to 4, hence it is a k worthy submatrix. Now while solving this, while coding this, if you start with this, and then you find this, then you find this, if you just go with the approach of traversing through every square matrices, finding the sum, the complex, I don't know how large the complexity would get. It would be order of n into n square into n cube into n to the power. It would be a huge complexity. So what is the other way of solving this problem? Let us now discuss that way. The order of one approach. Now this is a famous submatrix query sum problem. We would find its implementation in our next video, which will be uploaded in the algorithm playlist. Do subscribe and do have an eye on it. I'll be uploading it recently. The approach and the implementation will be discussed there, but the solution to the worthy matrix, you have to do it. I'm just defining a perfect approach to such a problem. Now the idea here is, now see, firstly this is our given k matrix, k worthy matrix, right? Now the idea here is to create an auxiliary matrix such that the auxiliary matrix stores sum of elements in the submatrix from 0 to I of j. I'll explain this, wait. Now here is where we created an auxiliary sum matrix for this k worthy matrix. Kaise? Now the first element is 2. Fine, the first element is 2. Second element is actually a summation of this element and this element, which is 4. 2 plus 2 is 4. The third element in the auxiliary sum matrix is a summation of 2 plus 2 plus 3. That's 7. Here, this value is a summation of 2 plus 5, 2 plus 3, which is equal to 5. This value 11 is a summation of 2 plus 2 plus 3 plus 4, 11. 19 is a summation of 2 plus 2 plus 3 plus 3 plus 4 plus 5. 33 is a summation of all of these. So can you understand what an auxiliary sum matrix is? It's a sum of all the values from 0 0 to I of j, to that cell, right? Now we have created an auxiliary sum matrix, which won't take much time. It would definitely take something from order of n to order of n, n, 2n, 3n. It might take something like that. It won't take much time. Now how do we approach from here? We have found the auxiliary sum matrix. Now let me define few things. Here TLI represents row number of the top left query of the submatrix. Now suppose, let us just understand this. Suppose we have this submatrix and I want to find the sum of this submatrix. I need to find the sum of this submatrix from this auxiliary matrix in order of one time. How will I do? How will I do that? We will be doing it using this thing. It's very clear and it's very intuitive. This is a formula framed from basic intuition and nothing else. So it says that if I need the sum of this particular submatrix in the auxiliary sum matrix, I do something like this. You can pause the video, you can understand what's written here, but I'll just quickly hover you over the example. See, if we need to find the sum of this, firstly, what is 33? 33 is the sum of this entire matrix, right? And if I need to just find this, don't you think we need to subtract the sum of this and the sum of this to get this? Correct. So we subtracted 33. We subtracted 9 and 7 from 33. What are 9 and 7? 9 or 7 are basically summation of this row, this column and this row. Now can you understand that 2 is being subtracted 2 times? So we add a 2. So to find the sum of this from auxiliary sum matrix in order of one time, what we did was we subtracted 33 minus 7 minus 9 and added 2. This is the exact way we write it in a code. I just explained it through an example. I created this auxiliary sum matrix from before. So can you just see how easily we found out the sum of this submatrix via this auxiliary sum matrix? Now once we get the sum of this, won't it be very easy to find the average of it and to compare it with k and see whether it is greater than k or not, and hence we can say that it is a k-worthy submatrix. So are you getting my point? Auxiliary sum matrix is the way into the going. Now the implementation of this code, this approach, this is a famous approach, right? The implementation of this approach, I'll be discussing it in a next series in my algorithm playlist. Just subscribe and get going with it. It will be uploaded soon. Do check out for the implementation, but the question doesn't end here. It's just the way you should think, and then you need to build it on from there and find a perfect solution for the worthy matrix. It's for you to learn, first learn and then apply it in the given problem. So probably I think I could help you a bit. Do subscribe to my channel and let's discuss the key takeaways. So to solve such a problem like worthy matrix, you need to understand 2D matrix manipulation very well. This what we discussed is a famous approach, submatrix sum queries approach. The next video is just on this and the implementation of submatrix sum queries. Algorithm playlist is being updated. Yeah, thank you for listening. Just a second, more explanation. Now you would be saying that now the only task that is remaining here is that you need to find these you need to find all your square matrices. So if you just can find the indexes of from the starting point till the end point, this to this, you can find the sum of it using auxiliary matrix, and that will help you a little bit in your code. That will give you a correct time complexity. Thank you so much. Do subscribe.